Hello everybody, my name is Chamundeshwari. I hope all of you is having a good day. This is a supplementary explanatory video for the analysis done on credit risk dataset, which is provided in .csv format by CloudyML to me as part of placement test series of it. And in this video, I'll be discussing 9 problem statements and how I have solved them. But before that, let me just give you a briefing about the data columns present in this dataset and the data cleaning steps that I have done to ensure a proper analysis from my side. We have a total of 12 data columns in this dataset, which are person age, person income, person home ownership, person employment length, loan intent, loan grade, loan amount, loan interest rate, loan status, loan percent income, CB person default on file, CB person credit history length. And then you will see over here that credit history length and the loan and the employment term is both in terms of years, and loan status of someone who defaulted is 1 and for someone who did not default is 0. Let me take you to the Power Query editor real quick and show you the data cleaning steps that I have done to ensure that the analysis is accurate. Just a moment. Okay. Here you could see that there are a total of nearly 3% null values for person employment length and nearly 10% empty values for loan interest rate. Over here, look over here. There are around 3% empty values for person employment length column and around 10% loan interest rate for loan interest rate column. And I have found out that the loan grade to which the loan belonged to mattered a lot in case of the loan interest rate. So I have imputed the null values in the loan interest rate with the median interest rate based on the loan grade the loan belonged to, and then I have imputed the missing values in the person employment length with 0 because I have assumed that the empty values pertain to someone who had no work history. And then I have changed a value of 123 present in the person employment length of someone who's age 22, which didn't make sense, so I changed the value to 1 to make a more meaningful analysis on it. Let's just start with the first question, which is using DAX, calculate the average loan amount and the average interest rate for each loan grade. How do these metrics correlate with the default rate? Okay, the visualization of my choice over here is a matrix, but before explaining it to you, let me take you to the measures table and show you the measures that I have done to answer that question, which is first average interest rate and average loan amount, which is just the average loan amount and the average interest rate. And then I found out the default rate. How did I find it out? By dividing the number of defaulted people with the total loans given. Total loans given is found out using the count rows option, wherein I counted all the rows present in the data set, and then number of defaulted people. I made use of calculate function and counted only the loan status which has a value of 1, which pertains to the people who actually defaulted. So these are the measures needed to answer this question. I found out all these measures and imputed those values into a matrix visual and found out that as and when the loan grade has increased, the average loan amount to increased and positively, and then the average interest rate per grade 2 increased and default rate 2 increased. So the loan grade to which the loan belonged matters to the default rate. As and when the loan grade increased, default rate increased because the interest rates too increased as and when the loan grade has increased. That's your answer to question 1. And then question number 2, create a report visualizing the distribution of loan status across different employment lengths and home ownership statuses. Which combination shows the highest default rates? Firstly, in this visual you could see, in these two visuals you could see the default rates. Default rates is highest for someone who lives in a rented home, and the lowest for someone who has their own home. And default rates are highest in the later part of the employment history, that is from 25 years and above, but the frequency of such employment is very less, so keep that in mind too. And you could see the default rates from 0 to the 15. 0 is highest, 1 and 2 is highest, and from as and when it crossed the 2 year mark, the employment length, it stably decreased, which is less than the average default rate for that years. It decreased, and from the mark of 25 years, it has increased drastically. For a more meaningful visual, you could see the default rate by home ownership and employment length visual over here. You could see it in this visual. See, look in this visual tree map, wherein you could see the major chunk belong to the rent people, because those are the people who defaulted the most, and then mortgage and others and own. In this, you could also filter out certain employment lengths, because those are the anomalies. It's not that you have those kind of employment lengths all the time of person who work for 25 years and 30 years, long years. So you could filter it out and see it more clearly, the trend. Let's just go to the next question. Segmentation analysis using loan intent. Segment the borrowers by loan intent and visualize the average income and the average loan amount for each segment, which intent has the highest loan amount to the income ratio. To find that out, I found out the loan to income ratio measure. I just divided the average loan amount with the person income, and the rest of the filtering is done through the filter context itself in this visualization, wherein I have imputed the loan intent into the x-axis and average of person income and average of loan amount onto the y-axis, and then just to show the loan to income ratio in the same visual, I have added another. I've used help of combo chart, and I have used line y axis, imputed its values with loan to income ratio. Using that, you could see that the highest loan to income ratio is for medical, followed by education, and the lowest loan to income ratio is present for home improvement. But you need to look over the default rates by loan intent too, which is highest for home improvement than that of a medical, than that of education. Let's go to next question. Time series analysis. Considering CV person credit history length as a time dimension, analyze how the default rate has changed over the years. Implement a time slicer to adjust the review period. To able to answer that, I have made use of line chart. Look over here, line chart, wherein I have imputed the x-axis with the credit history length, and then y-axis with the default rate, which I have computed priorly, and then I have inserted a slicer, which is credit history in years, and using the format option, I have changed the slicer setting style to in between, so that I could adjust the values of the credit history and look at the trends more clearly, more minutely. Like over here, you could see it over here from 2 to 14 years. This is the credit history trend, default rate trend based on the credit history present to us, and then over here from 2 to 22 years and 2 to 30 years. This is the trend. Let's go to next question. Predictive analysis and what if analysis. Create a what if parameter to stimulate different scenarios based on varying interest rates. How do changes in interest rates potentially affect the default rates? Okay, you could see it over here. Look over here, interest rate adjustment table. This thing, how did I do that? Making use of new parameter. I've kept it as numeric range, and I have named my parameter interest rate adjustment, and the data type to decimal number, and the minimum value to -5 and maximum value to +5, and increment as 1%, 0.01, 1 basis point, and the default is 0. And I have selected add slicer to this page, which would give you this particular slicer to us interest rate adjustment. And using these values, I have adjusted interest rate adjustments over here. Generate series -5 to 0.1, that's what I have done. And interest rate adjustment value, that is based on the selection that I will make in this particular slicer or anywhere. And then adjusted interest rate, I found out using, it's a measure, found out using average interest rate, and I added the interest rate adjustment value, and then I have predicted the default rate. In this case, I have the adjustment factor that I have used is that for every 1% interest rate change, there's a 5% change in the default rate. That's what I have used. And I have used baseline interest rate as the average interest rate for the entire data set. And then I found out the adjusted default rate by adding the base rate, that is the base default rate, with the adjustment factor. As and then making use of this slicer, you could see it over here as the, let me take it to 0. Yeah, look into this visualization. This is the adjusted interest rate for now, which is the same as the actual interest rate because there's no adjustment at 0% interest, which would be the base, and this would be the default value. Okay, as and when the interest rate increased, the default rate too increased. Observe these values. And then as and when it has decreased, the values to decrease, the predicted default rate to decreased. That's it. And then what's the next question? Geographic data exploration. If geographic data were available, how would you visualize loan distribution and default rates across different regions? Well, for starters, we don't have that geographical column in this data set, but you could always make use of map visual in this case, or also a fill map or a shape map. We could make use of n number of maps over here, and then make use of color saturation. For location, you would give the particular city or state, and then for color saturation, you could make use of the default rates, wherein the highest colored would showcase the region with the highest default rates, and the lowest color saturation would give you details about the regions with the lowest default rates. Or you could make use of a bubble size, and give it the default rate option, and using the legend you could give in different loan intents or loan grades. It would divide your bubble chart into a pie chart and would show you the proportion every time. You could do it either way, but for now we really cannot do that over here because we don't have that such kind of information in this data set. And then advanced DAX for risk assessment. Write a DAX formula to calculate the risk score for each loan, considering factors such as loan amount, percent income, default history, employment length. Define the risk score formula based on these factors. Okay, let me take you to the problem statement solution. Okay, I've created a calculated column, and I have taken the highest risk would be to the loan contribution. I have divided the average loan amount with the max loan amount, and have contributed the maximum risk to the highest loan because it's just common sense. The higher the loan amount, the more would be the risk. And the next would be the percent income contribution. If the loan amount to be repaid is lower in relation to the person income, he's definitely going to be able to repay it. So based on it, I have put the risk score, I have weighted that particular risk as 0.3, and then person who defaulted, I put the value as 0.2 based on the default credit history, and then based on the employment length, I have put different risk scores. For someone who has lesser employment length, the risk is more. For someone who has more employment, the risk is less. Based on that, I have found out the risk score. That's it. And then security features for sensitive data. Implement row-level security to ensure that users can only view the data relevant to their specific region or department. How would you set up these rules? How would I set up these rules? Well, again, using the modeling tab itself. In manage rules, you could see that one I have already done. I have assumed that we have a separate department for the personal loan, and only the persons who belong to personal loan department should be able to use personal loans. So I have put the loan intent to personal, and we close it over here. Let me show you as view as say personal loan department, I would be able to see see, look over here, only the value for the personal loan department. Stop viewing. This would show you the overall department. That's how it's done. And then after doing this, I have to share this particular Power BI file to the Power BI service and to the my workspace or any other workspace that you need. And then in the data set, I would keep the controls to include only this particular personal loan department, and I would do all of this before sharing it, after sharing the file to the while sharing the file to the personal loan department itself. And then dashboard creation and publication. Design a comprehensive dashboard that includes all of the above analysis, include navigational features and tooltips. How would you publish and share this dashboard with stakeholders in the Power BI service? Well, you could just publish it, excuse me, by using the Power BI service over here. You could publish it to the My Workspace or any other workspaces that you have created. What are workspaces? Workspaces are like folders, but on a cloud service. Power BI service is like a cloud service where you could create dashboards and share your work to the different collaboratory teams that you have. I will publish it like that. And for the interactive option, I have opted for the filters, and for showing more in-depth analysis, I made use of bookmarks. Look over here, you could see for more in-depth analysis, you could press over here and you could see the default rates based on home ownership and employment length, and you could further divide it based on filters too. And then the credit risk analysis based on the loan to income ratio and the default rates for that particular loan intent. And again, you could slice it up based on the different filters available to you over here too again. And then you could see the credit history default rate, and you could adjust it based on the slicer value, and it gives you the interactivity that you need. And then for further values, you could see the what if analysis, that is the probability. What happens if the interest rate is so and so? What would happen to the default rate? That's the values that we are dealing with over here. And then this is the matrix visual of all of those things. That's it. You add it up, you see mortgage, and then a more in-depth analysis into this. Again, back to start. And I have made use of tooltips too over here. Say for example, the rent is defaulted 31.57% is highest default rate, and the number of people defaulted is 5192, and the total loans given for that particular people who have rent own, who have no ownership of their own but rent type homes, it's 16,446 are the total data set. So we could make use of tooltips and give additional information too. That's how it's done over here. Thank you for this opportunity.